This is the video where we get to put everything all together, all the different transformations that can happen on a function. Before we do that, let's go down to our little review chart of what happens when certain things happen to our function. So again, I know this is absolute value because I have the absolute value mark. Notice here in the front, I have this -1. So when I have a negative number, don't care what kind of number it is, this negative here, see if I can find a different color pen, I don't know if we're going to see it, but this negative here, if this number being multiplied is negative, number is being multiplied to the absolute value, it does a reflection over the x-axis. Okay? So you can see, depending on where the number is, makes a change or a transformation of the function. So let's go ahead and look at this function here. So when I'm looking here, I got to say, okay, what kind of function is it? Right now we're just looking at absolute value, but I could give you quadratic, or I could give you a log, something else, something different, and it would, I need to recognize that. So the parent function here, the bare minimum I need is the absolute value of x. Now I'm simply writing this y equals, just to show you that f of x is the same thing as y equals. I could write it like that. Okay, so my parent function is the bare minimum I need. If I take all the numbers away, I'm only left with the x, and the x is inside those absolute value marks. So that's how I get my parent function. Okay, so let's look at what's happening around my absolute value. Okay, so if I were to look inside at the x, notice this says +2, but my formula is minus, so that means that this needs to be a -2, because a minus times a minus gives me a plus. On the outside, I have a -1. Okay, so that's on the outside. So before I go any further, remember the inside that's happening to my x is my h. So that means that my vertex is -2, opposite of what I see here, comma, -1. That's my k. Okay, so this is now my vertex. So if I were going to start graphing this, I would start at the point -2, -1. -2, -1. So -2, -1 is right here. So we can already see that there was a shift left 2, down 1. So for the transformation, I can write left 2, down 1. And we get it from here. Left 2, opposite what I see, down 1. Okay? I have this thing happening here in the front. Before I do that, axis of symmetry. My axis of symmetry comes from the x value of my vertex. So that means my axis of symmetry is x equals -2. Okay, and in fact, I'm confident enough that I'm going to go ahead and sketch it in. I'm going to go ahead and put in where my vertex should be. So you can see my vertex is not the y-axis in this case, because everything has shifted to the left. So I can say that my axis of symmetry is where x equals -2. It has to be an equation. It's an equation of a line. Okay, so what do I remember about negatives and these numbers? Well, let's write this here. That's in the front. I have a negative, and then I have a 3. Okay? Well, let's think about what do negatives do. Negatives. If I look here, a negative reflects the function over the x-axis, which means this is probably going to be upside down. And what does the 3 do? Well, if I look here, is 3 bigger than 1? 3 is bigger than 1, so that means we have a stretch, which means my function probably gets skinny. So I'm going to go ahead and write these things down. I have a stretch of 3, which is what that 3 is doing there. And then I also have a reflection over the x-axis. That's what I'm going to abbreviate it. Reflection over the x-axis. That's what rocks means, okay? And in fact, down here, let's go ahead, the reflection over the x-axis. That's where I get rocks. Okay, so that's what that abbreviation is. Okay, so let's go ahead and let's just graph this. So I'm going to clear everything out. I'm going to put in -3, absolute value of x, oh, I should do it from here, of x plus 2. Make sure you get outside of your absolute value mark, and I'm going to put in a -1. I'm going to always look at the graph to see what it looks like, but I never graph from here. Okay? So I can see it's upside down. I can see the vertex is not in the center and it's down a little bit. So now I'm going to go to my table, and I'm just going to pick something that I can graph. Let's just start from here because that's what was given to me. So at 0, -7. So at 0, I have -7. Then at 1, I have -10. I can't go anymore because at 2, I have -13 and I'm off the graph. So I'm going to go the other way. So let's look at -1, -4. -1, -4. Okay, notice how I went very nicely up to where my vertex is. And then I have -2, -1, which is what I plotted. And then I have -3, -4. -3, -4. I'm coming back down again. Okay, this is what was expected. And then I have -4, -7. -4, -7. And if I go up one more, -5, -10. Okay, so I can now draw this in. And my vertex again is right here. That's my vertex. That's at the point -2, -1. I already did my axis of symmetry. You can see it got skinny and it also went upside down. So that's putting all of everything together that we looked at in their individual parts together as one. And we got one more of those to do. So let's do one more in the next video.